Hi everyone, this is Rakshita BK studying at Sri Venkateshwara College of Engineering in the Department of Electronics and Communication. Today I am going to explain you about the optical and wireless communication. The topic is wireless network generations from 6th to 0 to 6th generations. Next we'll see the introduction. Wireless network generations represents the technological evolutions of mobile communications from basic analog systems to advanced digital ecosystems. Each generation has brought significant advancement shaping the way we communicate and interact with the world. Starting with the zeroth generation, which introduced the basic voice communication without cellular structures, the journey progressed to 1G, the first true cellular system offering analog voice services. 2G transfers to digital communication, enabling services like SMS and MMS. 3G introduced mobile broadband, paving the way internet access on go. Then 4G connectivity with high-speed internet and seamless multimedia streaming. 5G brought unprecedented speed, ultra-low latencies, and massive IoT connectivity. The anticipated 6G generations promises the transformative technology, including terahertz communication and AI-driven networks, pushing the boundaries of connectivity and innovation. Each generation has built up in predecessor, shaping the future of communications. Next, we'll see the wireless network generation from 0 to 6th G in first is 0th generation. The 0th generations of wireless networks, also known as pre-cellular network, marked as earliest stage of mobile communication, emerging in 1940s and evolving through the 1970s. These systems were entirely analog and primarily used for basic voice communication. Unlike modern cellular networks, 0G lacked the concept of cell-based architectures, meaning that communication was not handed over seamlessly as users moved between regions. Instead, relied on large signal radio transmitters that provided coverage over broad areas. Technologies like mobile telephone systems, improved mobile telephone services, and push-to-talk system were common in this era. Devices were bulky, often installed in vehicles due to their size and power requirements, and had limited availability for the public due to high cost. The zero-G systems were the foundation for modern mobile networks, but they suffered from poor call quality, low capacity, and lack of security. These limitations eventually led to the development of the first generations of cellular networks, which introduced cellular infrastructures and improved mobility. Next, we'll see the first generation, that is 1G. The first generation wireless networks introduced in 1980s was the first true mobile cellular communication system. It marked a significant leap from the pre-cellular zeroth generation system by introducing the concept of cell-based architecture, allowing the users to move across different regions while maintaining a connections through hands-offs between cells. The 1G networks are entirely analog and designed primarily for voice communication. Technologies such as advanced mobile phone systems and were among the prominent stands of these generations. These networks provided greater coverage and mobility, enabling mobile devices to become more vertical for everyday use. Every 1G had several limitations. Call quality were often poor with significant interference and noise. Security was minimal, making it easy to eavesdrop on calls. Additionally, these networks had low capacity, limiting the number of users they could serve simultaneously. The devices used in 1G system were bulky, expensive, and consumed a lot of power, making them inaccessible to the average uh, consumers. Despite these drawbacks, in 1G network laid the groundwork for the digital revolution in wireless communication, leading to the development for more advanced systems like 2G. Next, we'll see the second generations, that is 2G. The second generation 2G of wireless network introduced in the early of 1990s marked a pivotal shift from analog to digital communication. This transition significantly improves the quality, security, and capacity of mobile networks. 2G networks use technology like global system for mobile communications, code division multiple access, and time division multiple access to support digital voice transmission. One of the key innovation was introduced the next message and multi-messaging, which transferred mobile devices into communication tools behind voice calls. Additionally, digital encryption enhanced call security, reducing the risk of 2G also laid the foundation for mobile data services with speed up to 64 kbps. Later enhancements such as general packet radio service and enhanced data rates for GSM evolution boosted data speeds to around 256 kbps, enabling basic internet access and applications like email and web browsing. Next, we'll see the third generation. The third generation of wireless networks launched in an earlier 2000s revolutionized mobile communications by introducing true mobile broadband capabilities. Unlike its predecessors, 3G was designed not just for voice communication but also for data intensive technologies like universal mobile telecommunication system and later advancements, that is high-speed packet access enabling data transfer rates ranging from a few hundred kilobits per second to several megabits per second with the theoretical speeds up to 2042 Mbps in enhanced versions. Network utilized packet switching technologies for data transmission, making them more efficient and capable for supporting a wider range of services. These generations also introduced the video calling and supported applications like mobile TV and GPS navigations. Next, we'll see the fourth generation, that is 4G. The fourth generation wireless network introduced in the late, that is 2000, has marked a transformative leap in mobile communication by providing high-speed internet, low latency, and seamless connectivity for a wide range of applications. Next, technologies like long-term evolutions and its advanced versions, that is LTE advanced, enable data transfer speeds up to 1 Gbps under ideal conditions, allowing user to stream high definition videos like participates in video conferencing and enjoy real-time online gaming with minimal delays. 4G also introduced voice over LTE, which significantly enhanced voice call quality compared to earlier generations. 4G networks expanded global coverage and supported mobile hotspots, enabling connectivity on the go of multiple devices. Despite its revolutionary impact, initial deployments, 4G faced challenges such as limited rural coverage and higher cost for infrastructures and compatibility devices. Then, non 4G set a new stand for mobile communication and laid the groundwork for the ultra fast low latency capabilities of 5G networks. Next, we'll see the fifth generation. The fifth generation of wireless networks introduced in 2020s represents a significant leap in mobile communication technology, offering unprecedented speeds, ultra low latency, massive connectivity with theoretical speeds reaching up to 10 Gbps. 5G enables real-time applications like augmented reality, virtual reality, and autonomous vehicles. In ultra-low latencies, often below 1 milliseconds, it's crucial for mission-critical applications such as remote surgery and industrial automation. 5G utilizes advanced technologies like millimeter wave, massive multi-input, multiple output, and network slicing, which allows services for different industries. It also supports massive IoT, Internet of Things connectivity, billions of devices seamlessly. Despite its capabilities, 5G faces challenges like high cost of deployment, limited range of millimeter wave frequency, and need for extensive infrastructures and upgrades. Next, we'll see the sixth generations. Looking ahead, the sixth generations of wireless networks expected by 2030s aims to push connectivity to the levels, which projected speeds up to 1 Tbps. 6G will focus on integrating cutting-edge technologies such as terahertz communication, then artificial intelligence-driven networks and holographic communications. It promises enhanced sustainability, energy efficiency, and seamless integration with extended reality applications blending AR, VR, and mixed reality into daily life. 6G is expected to enable innovations like autonomous systems, global digital twins, and brain-computer interface transforming the industries and lifestyles. However, its development will face challenges such as high power consumptions, the complexity of new technologies, and need for global standardizations. Together, 5G and 6G represents the pinnacle of wireless innovations shaping the future of global communications. Thank you.